Welcome to Term 1, Week 4 of the Engineering Studies course offered through the School of Now. Okay, let's get straight into it. No more mucking around. We're used to our tabs, so I'm going to go here to Current Topics. And I've got my Week 4. Click on that. So again, you can see the navigation's all simple and it's all aligned, and it gets you to where you want to go quickly. Now, in this course here, basically the way it's all set up is that with the mathematics, or basically with the whole course, there's an introductory unit and then there is the household product unit. Now, I'm combining both of these, so we'll make sure that we do cover all the content, but I'm doing it when it's actually relevant. So, for example, we'll be talking about levers, inclined plane, screws, wheels, axes. This is more in line with and can be better taught when we're looking at actual products, okay? So here we'll start doing this, like mass, force, vectors, and scalars. We will mention some of this stuff, but this will come through later on as we're teaching as well. So a lot of it's repeated, like we're going to go learn the basics, then apply it, learn a little bit more, apply it, learn it, apply it. So it's sort of bouncing around a little bit more, but we will cover all of these topics as we're going through. Learning intentions, success criteria. So the activities that we're looking at this week, there's 3 videos to watch before the Zoom, looking at the importance of math and then reviewing some of the basic stuff around the SI units. Okay, so the SI unit stands for the International Systems of Units, which are the conventions that we use worldwide. It's basically in French, like SI for Système International. Please excuse my accent. But the whole idea with this is it's in French because they're the ones that store the standard. In a museum over there, they've got them under glass and they keep looking after them and making sure they're correct. And that's why it's got SI as a French acronym. In the Zoom this week, I'll go over and cover the basic math structures, so you'll have a look at that and we'll ask some questions. And there's also the learning content, which is on mechanics. So you've got an opportunity to start looking at what SI is and doing some basic maths. Right. Now, for the actual discussion this week, I know I'm smashing you guys with a whole lot of work up to week 4, okay? So the first thing we're looking for is perseverance. Are you keeping up with the work? Now, trust me when I say, I know it's a lot of work. I know it is. So I want to see where you're actually going with it. What I'd also say is, well, again, keep communicating with me. Let me know how you're going and where I can help. Okay. The second part of the discussion this week is around the idea of offering helpful advice to others. How are they coping with the workload? What tricks can you actually learn in order to be able to get ahead of the work, get ahead of the game? What can you actually do? Okay? Look, I know this is hard and we're trying to work through it and get some organisation and get it happening, lots and lots of new. But like I said, this course is all about the breadth of knowledge and the amount that we're actually doing so you can actually see and calculate and do the work as intended. Okay? What I'm trying to say is, if you're not keeping up with the work, that's okay, but tell me. Communicate with me what's actually happening so I can put in plans how we can actually fix it and make sure it works for you. Okay? So let's moving on. Next, using the navigation down the bottom again. Next. So here's a couple of little videos that we're just having a look at it. Everyone's favourite math teacher, Mr. Eddie Wu, is there to go over where math is, where you wouldn't realise where it is existing in society. So have a listen to the man himself. Here's some engineering gone wrong. So if you get the math wrong in the real world of engineering, there can be some pretty big problems. They're not going to be able to straighten this bridge in any time quick. Down here, it's a review of the SI measures. Again, I'm pretty sure you would have been covering this in your stage 5 science somewhere, maybe in your math as well. So again, it's just a review to make sure that everyone's on the same page and they know what they are doing. Here is our Zoom, which is the next one. And again, I'll be looking at what they call space diagrams. And a space diagram is actually a real world picture. From that real world picture, we're going to be breaking it down into a mathematical equation that we can do. So basically taking the real world, turning it into something that we can actually make a mathematics equation from. And I'll be showing you how to do that. Also, we'll be going over some of the math, so don't panic. Right, basic math, and like we're talking here about definitions here as well. So like, we've got quantities of time, and what we actually use is seconds, okay? When it comes to mass, we're talking about kilograms, okay? And it goes on and on. These are the standards that we're actually using when we're starting to calculate out different items that we're working with. So whether it be electric currents, and we're talking about amps, or whether it's actually length, and we're talking about meters. We also get to a stage where you can imagine it gets like the numbers get really, really, really big. Okay, so we're looking at prefixes and suffixes, right? So here, prefixes, suffix, what am I talking about? Prefixes to actual words. So like we've got tera, which is 10 to the power of 12, which is a billion. I think that's a million, no, it's a trillion, okay? So again, here we're looking at the different numbers and how we can shorten them when we're doing calculations, okay? So you need to understand how that actually works. So here, 10 million newtons equals, 10 mn equals 10 million newtons, which is 10 to the power of 6 newtons, okay? So we're just shortening it that way as well. Scalars and vectors, right? Knowing the difference between those, the idea that the scalar only requires only a magnitude, so it's the size of something. 10 kilos, that's a scalar, okay? 10 kilos, okay? When you actually apply that with a direction as well, so you've got your scalar and a direction, then we've got a vector quantity that we can actually measure. So forces, displacement, acceleration, and momentum. So we've got an idea, better understanding of how it works. Okay. Starting to look at the drawing of it, how we actually draw these forces. So here we've actually got magnitude, which is the power of the force. We've actually got a direction, which is giving us the arrowhead, where the start of the force actually is, traveling from as well. Okay, so there's all these different things that go into these drawings, and that's what I mean about looking at the different sorts of diagrams and how we draw them. A few little examples there of how we do drawings. Video on mass versus weight, have a look at that, which is good. And then some other little videos to introduce you to the force, from space diagrams to free body diagrams to see how we're drawing it. Here in this section, this is, if I click on this here now, you'll find it will actually take you to the Hsc Formula Sheet. This is a 2013 version, but it hasn't changed since then. Okay, so all of these formulas are the ones that you might have to use in your exam. Okay, so we're going to be starting to learn some of these. So definitely force equals mass by acceleration. We're looking at those ones there, or mass equals force by distance. So we're starting to look at these ones this year and some of these others as we're working through. Coming down, Pythagoras, we'll be using that. We'll be looking at SOHCAHTOA. We're looking at the cosine rule. So all of these good things that you would have been doing in stage 5, we're actually going to put them into real world applications to calculate out engineering problems. Next, evidence of learning this week. Here, it's a 19-page document. Again, click on here, make the copy for yourself. And again, I want you just to test your knowledge and see where you're at. Okay? Again, I need you to actually create that folder for me, set it in that folder so I've got access to it. And also in this case here, there should be a button on the next page that will allow you to submit it. Okay, so again, a little bit of explanation in here as well with some of the work calculations before you get down to the bottom where it's going to ask you to provide some answers to the questions. Okay, a little bit of reading, a little bit of work to do there. Yeah. You can see here, start assignment. So when you want to submit the assignment, I'll click on this here. I can file upload. I can actually give a Google Drive location as well. Oh, not available while masquerading. Oh, gee, I didn't realize I was masquerading, but I must be. Okay, so file upload, or even if you want to, send it to me via email so I can actually find your location of your work so I can mark it and give feedback. Next, leave. Now, with the math itself, like I said, from that last sheet, so if I go here on this sheet, you can see here I've got some exercises. So 3.2, right? I'll come back to here. Here is an explanation of how I did 3.2. Okay, so I don't want you looking at this straight away. I'd much rather you give it a go so you know where your learning is at. But definitely go back, cross-check if you want to, if you've got time to discover how I would go about it. Now what you'll find with the mathematics that I do, I actually go back to the very beginning and step it through one step at a time. I know some of you guys will be a whiz on a calculator and you just pump in the information, out pops your answer. But again, here, like I said, I will show you the working so you can get a better understanding of how it's done. For all the answers, they're actually here. And again, look, I know it's one of those things, like sure you can go here and click on it and get the answer and tick them all off and get 100%, but you're not doing yourself any favors. Try it first, try it. Then feel free to come and check and work out what you've done. If you're finding that there's still a gap in your knowledge between the answers and what you've done, that's where you hit me up and go, hey, need a little bit more help with this because I can't get my head around it. Trust me when I say at this stage, understanding these straight up, it is tough. Keep asking the questions. Communication is the key to winning here. Just because we all like math, here's another quiz for you. Okay, so there's another quiz to give that a go. Same deal, take the quiz, it's self-answering. So in this case here, I'll just give you a quick example. Right, here's the question, and then you just type in the number. Okay, type in the number for me so I know what it's actually coming to. Right. Give that a go and I will work it out and give you some feedback. So I'll just get out of this one. Quizzes, come back. Okay. Oh, I've done the wrong thing. Home. Current topics. Week 4. Next. Sorry guys, I'm just getting back into where we were up to. Next. Next. Basics next. Next. There's the quiz next. Okay, so again here, answers linked to the quiz. So they're available for you so you can see how they're actually done. Okay, so you can have a look there. The idea with this, like I said, if it was a situation where it would be in the classroom, then I'd be able to do these demonstrations for you live, but unfortunately I can't. So that's why we've actually got the links here to the answers themselves. Just click next here. Right. So again, the reflection this week is you're going to be marked on your ability to persevere, how you're actually going and how you're traveling so far with the challenges that you've been given. From there as well, I'm actually asking you to give some advice to your other classmates. Like, if you can help each other, you're going to do a whole lot better. So what I'm looking for here is, are you helping as a leader, instructing other students in the best way to do things and giving those hints and tips that will make things better for everyone. Like I said, as a cohort, if we work together and move forward, then we will all do better. And that's what we're actually looking at and expecting here. So the perseverance, you don't need to do anything except actually do the work itself. But here for this one here, for the actual discussion you're typing in here, is just your thoughts and ideas on how you got around the math, how you're getting around the course, and what things you are doing that's leading to your level of success. Okay, so that's it for the overview of week 4. Basically from here, I'll be seeing you in the Zoom. Bring your questions with you. Make sure that you have an understanding of what they're all about so I can make sure that I can help you out where needed. Thanks for listening, guys, and talk to you soon.